All right, let's finish section 4.4 with a really important theorem called the change of base theorem. So far, we've only been able to use a calculator to help us with a log if it's been base 10 or if it's the natural log. And what this is going to be able to help us do, this theorem, is it's going to be able to help us work in any base. And it's a pretty simple theorem, actually. So here's how it works. Let's say you have a log of some base on some number. So you're saying c to the what equals d, and say it's something hard like 3 and 7. And so 3 to the what equals 7. Well, it's going to be a decimal, but we can't use a calculator to figure it out. Well, here's what the change of base theorem says. This is equal to the log of d, the log of your number, divided by the log of c. And that's it. And you might be thinking, wait, what's so great about this? Notice this is log base 10. So we can use the calculator now. And it's as simple as that. So just take the log of this base 10 and divide it by the log of this base 10, and that's what this is equal to. So I'm not going to prove that in this class, but it's a really nice result. In addition, if you want to be more like a mathematician, mathematicians, us pure mathematicians, we don't like to use log base 10 very much because 10 is kind of arbitrary. We prefer to use the natural log a lot of the time, so you can also do this. So if you have log base c of d, that's equal to the natural log of this number divided by the natural log of this number, and this you can do in your calculator. So this is the change of base theorem. It's very important, and so let's just apply it to 3 examples, and then we'll be done. So here's example number 1. Find log base 3 of 6. Well, according to the change of base theorem, log base 3 of 6 is equal to log base 10 of 6 divided by log base 10 of 3. Okay, and that's it. So let's do that in the calculator, and let's also show that it's the natural log 2. So I can do the natural log of 6 over the natural log of 3. So let's show that these are the same numbers. So I'm going to do 6, take the regular log of it. I'm going to get approximately 0.778. Now let's do the log of 3. 0.477. And now if I do 0.778 divided by 0.477, I get an answer of approximately 1.631. So let's see what happens. I'm going to clear this. I'm going to take 3, our base, and take it to this power, and let's see how close we got to 6. So 3 to the 1.631, pretty close, 6.0004, and that would be more accurate if I had included more decimals after this. So that's pretty good. Let's do the natural log just to show that that also works. The natural log of 6 is approximately 1.7918. Natural log of 3 is 1.0986. And if I divide those, 1.7918 divided by 1.0986, I get an answer that's approximately 1.63098. So I did more decimals, and so this one's probably a slightly more exact answer. But you see how you get pretty much the same thing, 1.631, depending on how many decimals you went to. And that's really all there is to the change of base theorem. What is the log of base 13 to the 200? 13 to the what equals 200? Well, just use change of base. ln of 200 divided by ln of 13. So here we go. 200 natural log is approximately 5.2983. Natural log of 13, 2.5649. And then just divide those. So 5.2983 divided by 2.5649. So this is, I shouldn't use an equal sign, this is approximately equal to 2.06569. So if you take 13 to that power, you get about 200. If your homework is making you be extra exact, you should use more decimals than I'm using. This is kind of interesting. What is log of pi 80? So we can even use change of base theorem if our base is kind of crazy, like pi, a transcendental irrational number. So again, you have your choice. You can either use log base 10 or natural logs. I prefer natural logs. So natural log of 80 over the natural log of pi. So let's do 80, take the natural log. Now don't mix and match. You can't do, you can't do the natural log of one and log base 10 of the other. That would mess you up, so don't do that. Now let's do pi. Do I have a pi button? I do have a pi button. There's pi right there. Let's take the 3.141592653589979. Let's take the natural log of that. It's approximately 1.1447. And now we just divide 4.382 divided by 1.1447. So pi to the 3.828 is approximately equal to 80. So that's kind of cool. So just don't mix and match, and always make sure that this number is on top and your base is on the bottom, and that's how you use the change of base formula. And that concludes section 4.4. I think we only have one section left in chapter 4, so I will see you in section 4.5. If this was helpful for you, please make sure you like and subscribe. And if you have any questions, as always, leave them in the comments. See you on the next video.